Hi, Elizabeth here, production assistant for the PodRocket podcast. Before we dive in, did you know that PodRocket is on YouTube? You can catch the full video versions of our episodes over on the LogRocket YouTube channel. Click the link in the description to tune in and subscribe so you never miss an episode.
Lingo.dev compiler is designed to eliminate all the friction that typically exists when developers do i18n internationalization. And maybe is the first tool that does it in such a way at build time.
Hello, and welcome to PodRocket, a web development podcast brought to you by LogRocket. LogRocket provides AI-first session replay and analytics which surface the UX and technical issues impacting user experiences. Start understanding where your users are struggling by trying it for free at logrocket.com. I'm Noel, and today we have Max Prilutskiy, co-founder and CEO of Lingo.dev, here to talk about the Lingo.dev compiler. In this episode, Max and I talk about the nuances of UI translation, localizing code bases, and the cost of maintaining that localization historically. So here's our episode with Max Prilutskiy. How's it going, Max?
Hi, everyone. Thanks for having me.
I feel like this is a fairly new tool that devs might not know about. Can you just give us the quick overview of what the Lingo.dev compiler is?
Yeah, sure. Lingo.dev compiler is our new open source, free and open source package. It's pretty much a library, a middleware for build tools such as Vite, or it can also be used with Next.js and React Router, formerly Remix. And what it does is that it makes your app multilingual. Basically, it implements i18n without having to extract strings from the code base, basically without having to rewrite the entire application, to refactor the entire application. And you don't have to change the components, wrap them in translate tags or in T functions. It just does that automatically. You just enable it and it magically works, and it does it at build time.
Does Lingo.dev specifically target React? You mentioned like Vite and like the other build layers here. Are we still only talking about React projects for the most part, or is there other support as well?
With Lingo.dev compiler, it's React projects and specific types of setup, namely it's Vite, React Router, and Next.js app router. But Lingo.dev main product is a localization engine and API that can be used not only with web technologies, but also like with Markdown files even, or mobile apps, Flutter apps, iOS apps, and things like that. But Lingo.dev compiler is specifically for React apps, and those particular setups at the moment. That's the starting point.
Can you explain a little bit more about what the compiler is doing specifically that's special compared to just like the larger Lingo.dev offering and how that kind of interacts with the React project structure?
Sure. For us, it's a very exciting thing that we always wanted to build. And we actually tried building Lingo.dev compiler a year ago, but we failed for a couple of reasons. And then we decided to give it another try, and we succeeded from the second attempt. But basically, so that you understand what it does and how it compares to other i18n solutions, is basically typically you would use an i18n library such as React Intel or i18 Next, or there's many of them, and they work in a very similar way. You have to install the library, you have to extract the strings that you are showing to the user on the screen. You extract them into JSON files. There are scripts sometimes to do that extraction in semi-automated way, but at the end of the day, you do the extraction step and you end up having JSON file in English. And then you translate that JSON file. And in the code, in order to mark some things as translatable, like elements, you wrap them in special functions, and you reference the actual messages that are in your JSON file by key. And then you either use formatted message component or T function, or sometimes you wrap pieces of text in your app and then you run a script to do that automated extraction. But essentially, it's about refactoring your code base and extracting translatable strings into a JSON file that then you pass through like whatever translation process you have. So that's the traditional, and now I would even say legacy way of doing i18n. Lingo.dev compiler is approaching the same problem, but in a slightly different way that didn't make sense before AI. And I will explain that in a second. But now it makes a lot of sense, and here's how it works. It's a compiler, meaning it's a build, let's say, stack middleware. It's a plugin. It's a Webpack, or we support different build tools. So it's a plugin, essentially, that works at build time. both in dev mode and in production builds. And it analyzes the code base, identifies pieces in React code that need to be translated. And then during the build time, it calls translation or localization AI, like API endpoints. We support several LLMs for that. And it creates those translations and stores them in the project. And that means that whenever, like after that, when the app is shown to the user, when it's run in dev mode or it's published in production mode, you see just English text first, but then you switch the language. You see the, let's say, Spanish version after that. But you didn't write any Spanish text. It happened during build time automatically. By the way, it's also customizable, but it doesn't have to be like you don't have to.
There's no necessary configuration.
But it's customizable at the end of the day. TLDR is designed to eliminate all the friction that typically exists when developers do i18n internationalization. And maybe a Lingo.dev compiler is the first tool that does it in such a way, like at build time. But honestly, we feel like it's such an obvious thing to some extent that all other popular React libraries for i18n, like React Into or i18n Next, they will at some point implement that. We feel that's a natural next step for all i18n React libraries. And also, there is also even a chance, we think, that Next.js or Remix, React Router now, will use the same concept, the same idea inside the frameworks themselves, because it's like it eliminates so much friction from development process.
Yeah, I've got a couple interesting threads I want to pull there, but I'm gonna circle back to them. I want to get a little bit more into the weeds here slightly on what is actually spit out once this kind of build time middleware compiler, like when it runs. Like for me, when I'm thinking about internationalization, one of the tricky things is like the way in which reactive text is composed can necessarily be different between different languages. The count is X, and in that being reactive, that X may be in a different place when the text is translated. When that reactivity needs to be added, like the awareness of that context, I feel was something that like when you were going through this internationalization process historically, it was like, that's why there was this like kind of format syntax, right? That was like contextual and you could like inject data into the output strings. Is that process still kind of the same? Is that still happening here? Or is there some other kind of magic that's making these simple strings into like function calls that are then usable so like data can be injected to build these new strings for other languages?
Yeah, that's a great question. And in fact, you're saying that the position can be different in different languages. It's always the case with Arabic, for example, or Japanese as compared to English. But also what's funny is that sometimes the number of parameters is different and the order of parameters is different. So in one language, you would have 3 variables. Let's say it's a message like you have like count notifications, right? So these types of things. And in another language, maybe it's going to be like 2 parameters instead of 3 and in different order. We support that. However, we don't implement our own standard. So we are following industry standards here and we are building on top of them. So for example, there are things like message format 2. Yeah, we are trying to reuse as much existing work as possible. And yeah, so it does work. It does work in the same way. It does support these dynamic variables inside JSX tags.
Gotcha. Yeah. Is that something the developer has to care about? Or is this kind of build time layer, is it like figuring all that out and doing it automatically?
Yeah, that's one of the most challenging parts, to be honest, of this processing that compiler does. So we wanted this to be automatic and the compiler does that automatically. There are several known limitations in terms of how compiler works and what it expects from the code base. And number one rule of thumb is that if you're showing a piece of text to the user and you want that piece of text to be multilingual, then it should be inside JSX. For example, if it's a variable, let's say const title equals whatever, hello world, and this hello world is a string literal, this will not be localized at the moment. To make it localizable, it's very easy. Actually, you just wrap it in at least React fragments, like with empty braces on both ends, and that's it. Span div obviously also work as well. So that's a known limitation / convention that Lingo.dev compiler is using. The main reason we are saying it's a convention rather than limitation is because it's nearly impossible. So we want the compiler to be able to process huge code bases up to 10 million lines of code, right? And to make that work, we need it to work predictably and deterministically. And the issue with string literals is that sometimes you would have like const, let's say const like type equals whatever. And that whatever is not supposed to mean anything to the user. It's just some system value that you're using internally. But in terms of like how abstract syntax trees work and how React code and JavaScript code is composed, it's impossible to tell the difference between something that user will eventually want to have multilingual on the screen or not. There is a convention that Lingo.dev compiler is following, and it's that you have to wrap translatable text in JS6.
Yeah, is that like a known convention? Did you guys pull that pattern from somewhere, or did that seem like the obvious place to delineate?
No, it came naturally, to be honest. We were experimenting with a lot of things, and this concept, it just came naturally. I don't know whether any other library is using that. I don't think so, because it's such a specific thing to compiler, like type of approach. So I don't think such thing exists somewhere else.
It makes sense as an abstraction because like you'd be opening up a whole can of worms otherwise if it was like any possible variable would need to be translated, because then it's like, well, maybe this is like a username or something in here. There's all kinds of funky.
Yeah, exactly. And also system design and React code quality wise, I think it makes a lot of sense as well, because React has always been this view layer of your application. You write JS6 and like HTML before that in order to display something to the user, to show something to the user, to let user interact with something, right? And that's why HTML exists in the first place. And then JS6 as like superset on top of HTML that adds this like JavaScript layer on top of HTML, right? So it's all about interactivity and communicating information to the user. So we feel it's the natural concept to keep in mind that if you want something to be translated, it should be in JS6.
I would imagine that also makes it simpler to do this kind of building of the translation layer with the only awareness needed being the AST itself. Can you talk a little bit more about like why the abstract syntax tree is a good kind of tool to help with this, and if there's any kind of information you guys can glean there to help determine how things should be translated, like what the chunks should be?
Yeah, it's a very exciting part and like the core part of how a Lingo.dev compiler works. And essentially, abstract syntax trees, they help us treat code as a very complex data structure. So that's why they're so powerful in this context, and that's why compiler is using them under the hood. We are using the industry standard tools under the hood, such as Babel, for instance, to do these abstract syntax tree manipulations inside the compiler. And it works elegantly. For those who have contributed to the open source repo that we have, yeah, you guys know that elegance, you saw that firsthand. But yeah, it's such a powerful mechanism to use inside the compiler because it can help infer the location of the elements, the meaning of the elements. Also, it helps, for example, there is this thing in React code bases that you can supply like arbitrary attributes to JS6 elements like data dash whatever, and your IDE, your ESLint, whatever they want, complain about it. So, for example, we are supporting data lingo skip attribute if you want to exclude something from translation, or data lingo override and then locale code if you want to provide like specific version for something, or like context also. So it helps with a lot of things, and it's a very elegant piece of technology, both Babel and abstract syntax trees, and it's just the perfect solution to be in the core of the compiler. Speaking of which, and I think I mentioned already that Lingo.dev compiler didn't make much sense before LLMs. And here's why. Technically, such library, such open source compiler could exist. Technically, it could have been built like 10 years ago, 20 years ago, because abstract syntax tree, computer science-wise, it's not a brand new concept.
Yeah,
right?
It hasn't really changed much in form.
Right.
Yeah.
But if you think about it, all right, let's imagine somebody built that compiler technology like 10 years ago, 20 years ago. And the result of the compiler working is like a metadata file, like a dictionary file that contains like the metadata and some pieces of text that need to be translated. And for humans who would translate that thing, it would be even harder to process and to work with that format. And then, all right, you don't have to extract strings. It's done automatically, but then you still have the file that you need to send to the person to translate and then to wait for the file to come back, right? It wouldn't solve much. It wouldn't solve many problems. But now, since AI is getting better and better with translations, and it can be supplied with all this contextual information, both macro context, meaning like about the product and the industry, and micro context about the position of that element within the context of the page, let's say. We can supply all that information to the LLM to create perfect translation in just a couple of seconds. And that means that the only blocker now is the developer experience and this extraction and this ongoing maintenance toll that every single team usually has after implementing i18n. These two things in combination, they are just like a perfect match to solve localization in web applications.
You talked a little bit about this micro context, I think was the term you used, but it's like context of the app itself and the shape and like where these strings are and how handing that off to a human could be difficult. I'm thinking back to the kind of old version of this where you have like giant localization files and it's here's all the strings. Can somebody like translate this into Spanish now or whatever? What do those kind of artifacts look like? Like, what do you actually end up now with when you have a build? Let's say you want to just go in and see what happened or debug something that was weird. Is that really possible? Or what is the actual code that ends up running and what data is stored to help it like do the localization process?
There are a couple of questions that you asked here. So first of all, what are the artifacts of Lingo.dev compiler? So the artifacts are basically a dictionary file and metadata file. And at the end of the day, those are the files that contain the text that is being used during the rendering phase, right? Technically, we can hide those files, not expose them to the developer. And the very early versions of Lingo.dev compiler were doing exactly that. But then we realized maybe it's too magical in some sense. It's like you're enabling something, you don't see any artifacts, and somehow the app is translated and you have no idea how it works. And we showed it to the users and they were like, this is complete magic, but I have zero visibility. I want to understand what's going on. We do expose metadata and dictionary files now. Developers are not supposed to touch them very often, but it's definitely possible. Whatever override is being made in the dictionary file, let's say, it remains there even if you rerun the compiler. So basically, it's like a cache. It's like persistent cache of the translations that exists inside the project itself. And it's very powerful because both metadata file and dictionary file, they contain this meta information, the translations themselves, and you can easily inspect that file and play with it if you want. It's not supposed to be worked with very often. It's being managed by Lingo.dev compiler.
You mentioned it's this like cache. What is keying on it? What would cause an override to be made to something that had actually been tweaked in one of these artifact files?
Usually when you change like the location of the element, it's being retranslated. And then if you change, obviously, the content, it's being retranslated. In terms of overrides that I just mentioned, that developers can always do, if they are done manually, through the dictionary file, not through data lingo override attribute, but like manually in the file, they will remain there and they will not be overridden unless they change the source version. So source version is the thing that we look at. And if source version changes, it means that it makes sense to retranslate other versions of that, let's say, paragraph as well.
Yeah. You talked about accuracy and knowing when these translations are right. Have you guys just found anecdotally that like we're at the point where these are usually good enough to just send, or are there any particular areas that it's tricky in like certain corners, or how's the efficacy been so far?
What do you mean exactly? The quality of the translations or the compiler developer experience?
More the quality of the translations. I think I'm more sold on the developer experience. My follow-up question was going to be like, are there ever any cases where you like alert to the developer? Do you give the capacity to the model to kind of throw its hands up and be like, I don't know, I need a human to look at this? Or is that not something you guys have encountered?
The AI quality part. So just to make it clear, Lingo.dev compiler is completely open source and free. And you can use whatever model you want with it for translations, like OpenAI, for example, and like Anthropic, whatever you want. However, you can also use it with Lingo.dev engine since recently as well. And it's very important to understand the difference because Lingo.dev is our commercial product, which is localization engine and API that is designed to produce perfect translations that match the product context and the brand voice and all the things that you want to have in perfect translations. For Lingo.dev compiler, translation quality is out of scope. There are ways to configure, as I said, the model that you want to use. If you use, for example, Lingo.dev engine with the compiler, then obviously that problem is solved because it manages all the contextual information, all these like sensitive brand voice settings and things like that. But if you're using OpenAI key, like raw, let's say LLM Access or Anthropic key, you can just prompt engineer the whole thing. There is a way to provide custom prompt, provide different models. For example, I want to use this model for Arabic, but that model for French, let's say. You can always do that. If you want to manage that manually, and system prompt can be configured to follow certain like brand voice and style. That is definitely possible, but quality-wise, for compiler, it's up to the user, honestly. So it's out of scope. Unless they use Lingo.dev engine, of course. In that case, we take care of that ourselves.
It feels like it would be in the purview of the engine to have some kind of like confidence or something reflected back to the developer, like when this process is running. Is there any like mechanism for feedback as this happens? Like, oh, I hit something, I made an effort at translation, but I'm not super sure on this. Or I don't understand what this word means. Is there any of that in here at all? Or is it kind of just like, no, that's up to the model? You like go kind of have to watch the output to see what it does.
Usually it's up to the model, and obviously with tools like Cursor or Claude Code, if you're feeling curious, you can just ask, hey, is this actually correct? And yeah, it's like as easy as that. And the answer will be that you'll be surprised with the quality most of the times. And with Lingo.dev engine, for example, we do more sophisticated checks under the hood when we manage translation quality, because there are certain industry standard scores that teams, localization teams usually use to understand how good the translations are. So we, at the very least, we monitor them. And then on top of that, we have our own benchmarking system that uses LLM as a judge to basically make sure that whatever response our API produces, it's best for that product. So we do a lot of localization QA work on our side under the hood.
I wanted to ask a little bit about if there are any potential other kind of gotchas in here, if using the compiler in general. Is there anything right now that's our potential pitfalls? Does it work with everything like server components and client components? Is that all seamless, or is there anything worth considering?
Yeah, that's a fantastic question. So there are three common ways to use Lingo.dev compiler. It's Vite, it's React Router together with Vite, and also Next.js app router. We currently do not support Pages router, only Next.js app router. We do support both client and server components. We even have a directive, like it's called use i18n. So it's pretty much like use server or use client, but it's for internationalization. And the reason is that for very large projects, you sometimes want to onboard them file by file to monitor for edge cases, those string literals that might exist, right? So you want to onboard the project file by file, and you can just flip the flag in the configuration of the compiler to only work with files that have use i18n directive, right? So we have that. So we do support, as I said, Next.js app router, both client and server components, Vite and React Router together with Vite. In terms of known limitations, as I mentioned, it's string literals. So whatever is inside JSX is translated, whatever is outside is not translated. And in terms of the experience and gotchas, so the situation is like this. Usually users, they find themselves in one of these two buckets. The first bucket is you follow the tutorial from the website, from the official docs, and it just works from the first try. Like you just follow the instruction word to word, and it just works. Your app is magically in all the languages you want immediately, in just a matter of seconds or minutes, depending on the size of the app. And then there is second bucket of developers who follow the instructions, sometimes not very carefully, just speed running through the docs without paying attention, and then something doesn't work. And when we start looking into those cases, usually it's that the setup in the Vite config, let's say, is very custom, right? Let's say it's your project that you use at work. You don't probably modify Vite config very much. For you, it feels like you're working with a typical React app. But actually, your app is not very typical if you look into your Vite config. And our job right now and we invest a lot of efforts into that, is to make sure that whatever custom setup developer is using in their React project is supported by Lingo.dev compiler. I wouldn't say it's an easy task, but it's for some weird reason, it's a task that we are extremely excited about, and we always looking forward to supporting as many such like weird and edge cases as possible. Yeah, that's what we are doing these days.
Does everything work pretty well with like static site generation mode, or do you need like a runtime piece to do the actual like localization lookup?
Yeah, we need a runtime piece, mainly due to some limitations that, for example, speaking of React server components and Next.js app router, right? Unfortunately, there are two ways how you can access, let's say, execution context or like request information from React server components. And it's either through headers function that Next provides or through, I think, cookies function, which is like similar thing, right? Because cookies are in headers, and that's it. So in order to identify the information like about the currently selected locale, we need access to runtime. We have a couple of crazy ideas what to include in the next version of the compiler, but yeah, that's in progress.
That was my next question. What's next on the roadmap? What are you guys targeting?
Yeah, we want to support Next.js pages router and static builds for Next.js pre-renders like SSG basically. So that's what's on the roadmap. And actually, that's not even the most important part. The most important part is that we want to support as many custom setups in Vite and Next.js as possible. And that's like number one priority. It's, as I said, it's open source and free, and we welcome contributions. And so far, we received some like very helpful contributions from the community supporting like several edge cases. Yeah. And it's just growing. So it's amazing.
Cool. Have there been any particular kind of standout cases that you can think of like the community having some weird edge case and like adding support for it themselves, or even just use cases where someone was able to use the compiler and it like really powered them up?
Yeah, there were a couple actually. Some folks are using Google models. They were using Google models, and we were like, most of developers, they either use ChatGPT API, like OpenAI API, or sometimes Anthropic API. And so we added support for those. And then somebody was like, yeah, can I add Google? And then they just went ahead and shipped the Google Vertex platform support. And then somebody from the community said, oh, we already are customers of Lingo.dev API and the engine. Can we somehow use that? And we were like, yes, sure, let's add that. So we obviously wanted to add support for that, but it wasn't the top priority because we were focusing on developer experience. And somebody from the community who was also the customer, they were like, yeah, let's do it. So let's have everything under the same umbrella. And yeah, things like that. Usually the contributions are super helpful. And sometimes there were edge cases with imports and types related to how abstract syntax trees work. And one of the open source contributors just saw the edge case and they just went ahead and shipped the solution. Yeah, it's pretty cool.
Nice. That's awesome. I'm going to do some quick lightning round questions here. These are all like going to be little one or two sentence, some of them are even one word questions, and then we'll wrap up from there. What is one word you'd use to describe Lingo.dev compiler? Takes a long time to write a short letter, doesn't it? Yeah.
One word or one phrase. Okay, one word.
Yeah.
It's a relief.
Ah, nice. I like it. Good one. Yeah, for sure. I feel like internationalization is when everyone wants to do it and they know they should. And it's just, you spend all your energy like building your core app logic and then you're like, internationalization. You want to do it, you should. It's like in the same vein as like accessibility and stuff. It's no, I need to do this, but you pour so much of your heart and soul into functionality. And then you're like, okay, I've got to dig a little bit more here. Any tool to make that easier and do it well is empowering.
And to add on top of that, I worked at a high growth startup as engineering manager some years ago. I was like planning the work for my team, and localization was always like one story point. It's like the minimal work that you can do is add like localization to one of the components. But actually that one story point, and it's like the minimal effort needed, was blocking the entire project because we were waiting for a translator to translate our like back button or like more sophisticated button. But still, it's like very easy technically, but you just somehow get blocked. And that's why the words to describe Lingo.dev compiler is relief.
What do you think the biggest misconception is about internationalization?
I think the biggest misconception is that AI does poor job translating user interfaces. I think it's the biggest misconception. And I think some people think that it does poor job, but actually, if you pick the right model, if you configure, if you spend some time, a fair amount of time on prompt engineering, you can achieve just phenomenal results translating user interface, localizing user interfaces. Of course, we save time with Lingo.dev engine that does that under the hood, like all this optimization and quality. But even without that, if you dedicate time, you can use AI models and produce phenomenal results for translations that will match brand, the voice, the tone, match the dimensions on the screen, which we do, for example, in Lingo.dev engine as well. So yeah, I think that's the biggest misconception about i18n right now.
Do you have a particular feature of the Lingo.dev compiler that you're proud of or you just think is cool?
Oh, of the compiler? Yes, absolutely. One of the things that we are excited about the most is that it works with hot module replacement as well, right? So it works it's a compiler plugin, right? And it works in dev mode as well. But what also is crazy is that you have just English text in your React component, right? And then you change a piece of text and you click save. And if you switch to the browser, you will see that piece of text updated in all other languages automatically, immediately, in just a couple of seconds. And first of all, this is something that we are extremely proud of, that we were able to achieve this developer experience, but also it wouldn't be possible without model hosting providers like Grok, for example, who give you this fast inference, like API for fast inference. And when it's used with Lingo.dev compiler in hot module replacement mode, it's just crazy. It's just magical. You update something that is in English and you see it updated in Spanish, and it's being done by AI, not by some browser built in Google Translate, by like high quality AI model. And it happens so fast. So all these combinations of features all together is just insane. And it's also free and open source. So you check it out to see how it works. Yeah, that's something that we are like proud of.
Maybe you just answered this next question then, but what is one thing you'd tell developers stuck using manual like localization, internationalization workflows currently?
Yeah, there are actually two things that typically the dev teams eventually, but developers in the first place get stuck with the most. Is the first one is that first of all you need to do the extraction. You have to extract all the strings into JSON files. There are tools that will help you extract those things. For example, some frameworks have CLIs that let you extract those things and do some code gen to replace like the text with the components. But also nowadays you can do it very easily with Cursor or Claude Code. You just tell it particular prompt to go through your files and implement i18n and extract the strings into en.json file, and it does that. And it does it perfectly. It creates the names for the keys and stuff like that, right? So this is typically the first problem that some libraries solve and Cursor can help with, right? But the second problem is that after you do that extraction, you end up having a refactored code base that have these T functions, translate components like formatted message components. And if your project isn't being updated often, then it's not a problem. But if it's being actively developed, then every time you have to rearrange things inside your component or update the text of the component, you would first search for that thing that you have on your screen. You will find it in your translation file. You will check what is the ID of the key, and you will search for that ID to understand where that text is inside your app. And this is crazy when it happens at scale in larger projects, and it's just this constant maintenance toll that teams have to pay after they implemented i18n. And with Lingo.dev compiler, it just doesn't happen.
Yeah, nice, cool. I feel like that is as good a call to action as any. Is there anything else you want to touch on quick, Max, or do you think we've wrapped here?
I think that's it. If you're excited about Lingo.dev compiler and the approach that we are taking, go check it out. Go check out our repo, give it a star, join our Discord, and give it a try. If you have any feedback or would like to contribute, just ping me on Discord. I'm online almost 24/7, shipping something always. Yeah.
Cool. Thank you for coming on and chatting with me and talking internationalization a bit.
Yeah, sure. Thanks for having me.